Today I saw a Stack Overflow question that basically asks, how can I make sense of an int pointer that is initialized like this? What is the memory layout? Is it a 4-dimensional array or something else? So let's investigate. First of all, we have to rewrite this into pure C because this IDE doesn't support C++. So that would be malloc 2 times size of int pointer. Okay, let's see if that works. Let's start the program. Yes, we don't use it, that's okay. So that's how it looks. So nothing 4-dimensional about it, at least not yet. So we have an array of 2 elements. Each of those elements is an int pointer, and A points to the first of those pointers. Hence it's a pointer. Okay, now of course the next step is we want to make this int pointer point to something useful. So that would be A0. A0 is this variable. A0 should be another dynamically allocated array. That would be 1 pointer less. Let's see if that works. All right, here we go. So here we have an array of int pointers, and this int pointer points to the first of those int pointers. Okay, so let's initialize the first of those as well. That would be 1 level of pointers less for the array element. Let's see how that works. Okay, here we go. It's starting to look a little boring almost. So here we have an array of 2 int pointers, and this int pointer points to the first int pointer. Okay, so let's go on. And let's allocate another array that has enough space for 2 ints. And then we reach the end of our pointer journey. So here we have an array of 2 ints. And this int pointer points to the first int. Okay, so now we can store something inside there. For example, the number 42. Let's see if that works. There we are. There's the number 42. Okay, now all those mallocs normally require corresponding frees. So if I now simply step over, I get a warning that I didn't really free my memory. That's bad. So let's free it in the reverse order. So first we have to free, we have to free this array. In order to free this array, we have to pass this pointer, and this pointer is A000, right? This is A0, A00, A000, and once we have freed that, we can free the level above that, then we can free the level above that, and then we can free our A. So this is the exact reverse order. Here was our first malloc to A, that's our last free. Second malloc is second to last free, and so on. So let's see if this works. So 1, 2, 3, 4 dynamically created arrays, and now they should get cleaned up in the reverse order. Okay, cool. Now, as the last step, is this the same as a 4-dimensional array? I would argue that it's not, because if you define a 4-dimensional array, you will quickly see that the structure is vastly different. Here you can see it. This is a 4-dimensional array. So this X is the complete array. Then we have X0 for the first dimension, the first element. Then X00 is the first element in the second dimension. 0, 0, 0 is here, and 0, 0, 0, 0 is here. So no additional indirection here. So if you know the dimensions of your arrays when they are known at compile time, there's absolutely no need to go through these pointer hoops. Okay, but I found that structure a little more interesting, so let's start that again, and let's end the video here.